Assalamualaikum and very good morning. My name is Muhammad Syanik. Okay, today I will present about question 4. A 35 cm long, 5 mm diameter nickel plate horizontal wire is submerged and electrically heated to boil 2 liters of water at atmospheric pressure. It is assumed that the emissivity of the wire used is 0.3. Okay, for question A1, determine maximum nuclear heat flux and wire temperature that can be attained. Okay, for this question, we assume steady operating condition exists and heat loss from the boiler are negligible. For radius, L equal to 0.0025 meter, diameter is equal to 0.005 meter, length equal to 0.35 meter, emissivity 0.3, volume of water equal to 2 liter, which is equal to 2 kilogram, and gravitational acceleration is 9.8 meter over s square. To get water properties, we refer to table A9. Density for liquid is 0.6 kg per meter cube. Density for vapor 957.9 kg per meter cube. HFG equal to 2258700 J per kg. Dynamic viscosity equal to 0.282 times 10 negative 3 kg per meter second. Prandtl number is equal to 1.75. CPL heat capacity 4217 J over kilogram Kelvin. T-set equal to 100 Celsius. Okay, for CSF, we refer to table 10.3, which is equal to 0.006. Then sigma equal to 0.0589 watt per meter from table 10.1. And then CCR equal to 0.12, we refer to table 10.4.
Yeah.
To get HFG, which is equal to 2258700 J per kg, we use enthalpy of vaporization, which is 40.657 kilojoule per mole. Number of mole equal to 2000 gram over molar mass of water, 18 gram per mole, which is equal to 111.11 mole. So we will get HFG equal to 2258700 J per kg. To get CCR is equal to 0.12, we use this formula. Then based on table 10.4, small horizontal cylinder, the length is between 0.15 and 1.2. Then we get this formula. The CCR is equal to 0.12. To find Qmax, we use this formula, CCR times by HFG times by sigma gravitational density of vapor square times by density of liquid minus density of vapor power of 1 over 4, which is equal to 10,000 1,018,200 watt per meter square. To get the S, we use Qmax equal to Q nucleate. So formula for Q nucleate is this one. Dynamic viscosity times by HFG, gravitational density of vapor minus density of liquid over sigma power of 1 over 4, then power of 1 over 2 times by CPL times by TS, T minus T set over CSF, HFG, Prandtl power of 3. The answer is 108.93 Celsius. For question 4A2, increase in the wire temperature as the operating point jumps such that a film of water starts to be observed on the wire. An attempt to increase heat flux beyond Qmax will cause the operation point on the boiling curve to jump suddenly above the melting point, which is approximately 1000 Celsius, resulting in burnout. To get vapor properties, we assume Tf equal to 1000 Celsius, Ts plus Tset over 2 equal to 1000. We assume the Tf. From Tf, we get the properties Kv equal to 0.1362 watt per meter Celsius. Density of liquid equal to 957.9 kilogram per meter cube. Density of vapor equal to 0.1725 kilogram per meter cube, and HFG is equal to 2258700 joule per kilogram.
Yeah.
CPV equal to 2471 joule per kilogram Celsius. Tset equal to 100 Celsius. Dynamic viscosity equal to 4.762 times 10 negative 5 kilogram per meter second. Diameter is 0.005. And sigma is 5.67 times 10 negative 8 watt per meter square Kelvin power 4. This is Stefan Boltzmann constant, difference with the previous sigma used for Q nucleate. The temperature need to be in Kelvin unit. So Q total, formula is Q total equal to Q film plus 3 over 4 Q rate. Formula for Q film is this one, and Q rate is this one. So after we combine the formula, we input all the data. Okay, by using Excel, we will get Ts equal to 2176.03 degrees Celsius. So the increase in the wire temperature is change of temperature equal to T film minus T max, which is 2176.03 degrees Celsius minus 108.93. So the final answer is 2067.1 degrees Celsius.
Hi, my name is Nohaliza binti Eden with the matrix number 50838. So I'll continue. 483, time taken to raise the temperature of cold water from 14 degrees C to the boiling temperature. So the heat capacity for water is 4.18 kilojoules per kilogram per degree C, and the volume is 0.002 meter cube, and the density of water is 1000 kilogram per meter cube. So the mass of water is 2 kilogram, and the change of temperature is 86 degrees C. So the heat, we uses the equation mc theta, and the answer is 718.96 kilojoules. So the power, we uses the formula 4.2 times the volume times the temperature change over 3600, and we get 0.2 kilowatt. To find the T, we use P equals to heat over time. So the time is 1 hour for the temperature, for the time taken to raise the temperature. Thank you.
Hi, my name is Muhammad Afiq Aidid bin Muhammad Lutfi, and my metric number is 50616. Today I'll answer the question: investigate the effects on A, B, and C if the emissivity varies between 0.1 to 1. First, we have to know what does emissivity means. Emissivity is the ratio of a surface ability to emit the radiant energy compared with the ability of a perfect black body of the same area at the same temperature. Emissivity is a dimensionless constant having values between 0 and 1, where the perfect reflectors would have emissivity equals to 0, and the perfect absorber would have emissivity equals to 1. Heat radiation can be calculated through this equation. From this equation, the relationship between Q rad and emissivity is directly proportional. High emissivity yields high radiation emission. Therefore, the heat energy in thermal process will be lost through radiation. Ideally, in boiling process, the main focus is to transfer heat from the heating element and water. However, this process cannot be achieved due to some loss. Emissivity is one of the possible reasons of heat loss. Different material has different emissivity. Polished metals usually has low emissivity, which is a good reflector, and other rough surfaces, metals or non-metals, usually has high emissivity, which is good absorber. Good absorber means the material absorb heat better. As mentioned, the main process of in boiling is to heat the water. With the presence of high emissivity material at the boiler, cause the heat transfer to the material instead. Therefore, the process is inefficient. The materials such as aluminium, zinc, and copper are good reflectors, where the heat is reflected by the container itself, which means the heat transfer from the heating element to the water is more efficient. To ensure the boiling process more efficient, use low emissivity materials in order to improve the system. As mentioned in the previous question, Q total is the summation of Q film and Q radiation. The question assumed emissivity of 0.3, which result Q total is equals to 1,018,200 joules. For example, if we use a lower emissivity, which is 0.1, we can see that Q total is equals to 712,416.8 joules. This is because the Q radiation is smaller. This condition is vice versa when the emissivity is higher. For example, emissivity is equals to 0.9. We can see that the value of total Q is much larger.
Hi, my name is Nur Farhani binti Ulman. My metric number 50772. So today I'm going to recommend on how to improve the performance of the current boiling heat transfer system. So one of the improvement is by coating the surface with a thin layer of very porous material. This is because a very porous material have cavities on the inside the porous network. So these cavities will act as a nucleation sites. So as the bigger bubbles release from the nucleation sites, so there will be more active nucleation sites for a continuous vapor formation. Okay, and then next is we can change or replace or coat the material of the container with aluminium or unoxidized copper because they have low emissivity, so they can reflect heat more, thus enhance the heat transfer. And then another way is to polish the surface with sandpaper to increase surface roughness. This is because the irregularities such as the surface roughness will serve as an additional nucleation sites during boiling. So it will also able to facilitate continuous vapor formation. Now we know that rate of heat transfer are strongly dependent on the condition of the heat on the heater surface, number of active nucleation sites in the surface, number of active nucleation sites on the surface, and also the rate of bubble formation on the site.
Hi, my name is Nuraihan binti Zapri with metric number 50806. Okay, today I will explain about the chemical industrial that relate to our question, which is question 4. Okay, one of the chemical industrial application is the boiler. A boiler referred as an equipment that acts as a closed vessel which convert water inside it into steam. The chemical energy from oil or gas are converted into heat energy by combustion. Then the heat energy transferred to the contained water through boiling. For example, to heat your home, you switch on the boiler with an electric switch. A valve open and the gas enter a sealed combustion chamber in the boiler through lots of small jets, and an electric ignition system sets them alight. The gas jets lay onto a heat exchanger connected to a pipe carrying cold water. Then the heat exchanger takes the heat energy from the gas jets and heats the water. Besides that, the boiler is also used to produce steam for a steam turbine. A steam turbine is powered by the energy in hot gaseous steam and works like a cross between a wind turbine and water turbine. So that's all from us. Thank you.